Section 403.2.2 in the New York State Energy Code specifies that all ducts, air handlers, filter boxes, and building cavities used as ducts shall be sealed, and that duct tightness shall be verified. So how's this done? In this video, we will examine test procedures for verifying duct tightness. There are several duct leakage tests that can be used. The one we'll look at here measures total duct leakage. This test can be performed before drywall, when the HVAC equipment and all the ducts have been installed, or it can be performed after construction, which is what we'll show. The principal tool for verifying duct tightness is the duct blower. We'll start by introducing you to this piece of equipment and then run through the procedures for testing total duct leakage. There are a couple different types of duct blowers on the market. In this video, we'll use one type, but it's not the only one available. The typical duct blower kit consists of a fan, which blows air into or pulls air out of the duct system, flow rings, which control fan pressure, and a sleeve and coiled duct for connecting the fan to a return register. A control knob lets you vary the fan speed, and the manometer reads duct pressure picked up by the static pressure probe. We'll be performing a total duct leakage test after construction, but the same principles would apply if you were doing it after rough-in. In order to generate a readable pressure difference within the duct system, you'll need to isolate the ducts from the house. To do this, go around and seal all of the return grills and supply registers, as well as the furnace filter slot. Be sure to seal completely around the diffuser handle. Next, connect the duct blower to the duct system. You can connect to a major trunk line, to the air handler, or to a central return grill. Here, we're connecting it to the return grill. Now turn the manometer on and hit the mode button 3 times until it reads flow at 25. Be sure you're reading for a duct blower by pressing the device button until it reads duct blower B. Before we can begin, we need to run a baseline test to account for any background pressures in the duct system. Click Baseline and then Start. After 20 seconds, or when the numbers even out, press the Enter button. Now you're ready to run the test. Start the fan and increase the speed slowly. You want to depressurize the ducts until the Channel A readout shows approximately 25 pascals. When conducting the test at rough-in, we're looking for a Channel B readout of 6 CFM or less. This represents total duct leakage at a 25 pascal pressure difference. If conducting the test after construction, we're looking for 12 CFM or less at 25 pascals. There are pros and cons to testing for duct leakage at rough-in versus post-construction. The big advantage of running the test at rough-in is that you can fix problems if the test fails. However, you have to have all the ducts in place, including returns, which are often not installed until later when the equipment is installed. Running the test post-construction has the advantage that there's more latitude in scheduling the test, and it is often cost-effective to run it at the same time you're testing the airtightness of the building envelope with the blower door. The downfall, of course, is that if the test fails, it's difficult to make corrections. The remedy, of course, is to be careful and precise with duct sealing to begin with. Of course, the easiest of all is to bring all the ducts inside the building envelope. In this case, duct tightness testing is not required at all. Running ducts within the conditioned space may take some redesign, but running duct in sealing soffits can create a stepped ceiling, which adds a nice design element.